Hello everybody. So you guys are going to be using the definitions of SOHCAHTOA to get the sine, cosine, and tangent. Those definitions again is sine, and you don't pronounce it sin, you pronounce it sine. It's whole word, it's whole name, sine, opposite over hypotenuse. And remember, whatever angle you're standing on, this is the name of the angle, then that's the opposite side. So it says find the tangent of A. So first off, you have to stand on angle A. Once you do, remember this is automatically its opposite side. It's opposite the angle. This would be its adjacent side. And this, of course, is the hypotenuse. Okay? If, for example, again, I'm only going to do it once in this lesson, if you were to stand at angle B, this becomes the opposite side. This becomes the adjacent side, and that's still the hypotenuse. So who is opposite, who is adjacent, depends on what angle you're standing on. Remember, uppercase letters are angles. Okay? So, standing on angle A, you want the tangent. Okay, so let me erase all this junk. Angle A, this is your opposite, this is your adjacent. Tangent is opposite over adjacent. So, opposites on top, adjacents on the bottom. That's the tangent of A. Done. Okay. Find the cosine of A. Cosine of A is going to be your adjacent side over your hypotenuse. So, standing on A, because it's talking about A here, this side is your adjacent, this side is your hypotenuse. So, adjacent over hypotenuse. That's the square root of 75 over 10. Now, you can't leave this like that. You have to simplify it. So, remember, 75 is 3 times 25. So, that's square root of 3 times the square root of 25. So, that's a square root of 3 times 5. And remember, this is going to pop in front. So, 5 square roots of 3 is the square root of 75. So I have to replace that with 5 root 3. So 5 square roots of 3 over 10, that reduces, whoops, already had the equal sign, so you got the square root of 3 over 2. That's your answer. Okay? The answer is square root of 3 over 2. Tangent of A. So here's A. So this would be your adjacent side. This is going to be your opposite side. Tangent of A is going to be your opposite over your adjacent. Your opposite side is square root of 28 over your adjacent side, which is 6. 28 is 4 times 7. So that's square root of 4, square root of 7 over 6. So 2 square roots of 7 over 6. And you have to reduce this. So you get the square root of 7 over 3. That's your answer. Okay. Sine of A. Sine is your, whoops, I said that incorrectly. Sine is your opposite over adjacent. Oh, that was tangent, opposite over hypotenuse. Oh my goodness. So you have to stand on A, because that's what they're saying. Opposite is over here. Hypotenuse is there. So the opposite over a hypotenuse is the square root of 48 over 4. So 16 times 3 is 48. So that's the square root of 16 square root of 3 over 4. This much is 4 square roots of 3 over 4. So your answer is just the square root of 3. Okay. Sine of A. Sine is your opposite over your hypotenuse, just like it was up above. Standing on A, this is your opposite, this is your hypotenuse. Okay, so now it changes up here, because what's going to happen is on these, everyone before it, the radical, the square root was in the numerator. Now what's going to happen is it's in the denominator. And to get that out of the denominator, remember, you multiply by the square root of 73 over the square root of 73. So when I multiply by that, Isn't the top and the bottom of this fraction the same? So I'm in effect multiplying by 1. When you multiply by 1, you don't change its value. Don't cancel this out. That's not what you do. Okay. 3 square roots of 73 over the square root of 73 times itself is square root of 73 squared. Doesn't a square and a square root cancel out? So I have 3 square roots of 73 over 73. You're not allowed to have a square root in the bottom of a fraction. Okay? So this is how you got rid of it. You multiplied by whatever that fraction was, or sorry, root was, top and bottom. Okay? Let's do some more. Tangent of A, this is your adjacent, this is your opposite. Tangent of A is your opposite over your adjacent. Okay? So 12 over square root of 52. I got a square root in the bottom, so I multiply the top and the bottom by whatever that square root is. So you get 12 square roots of 52 over the square root of 52 squared, because it's times itself. So the square and the square will cancel. So 12 square roots of 52 over 52. Now you certainly can reduce. We can do that right now, or we can just wait a second. 52 we got to look at just for a second. 52. If I divide it by 2, I get what, 26? Divide it by 2 again, I get 13. So that's 4 times 13, right? Is 52. Okay. So that's 12 square roots of 4 times 13 over 52, which this is going to pop out as 2. Square root of 4 is 2. 12 times 2, square roots of 3 over 52. Now start reducing it. Okay? This 2 would reduce and give you 26. Let's see, there's a 2 in the 12 and a 2 there. So it looks like 6 square roots of 3 over 13 would be your answer. Okay. Cosine. Cosine of A is equal to your adjacent over your hypotenuse. So adjacent, if this is A, this is your adjacent side, this is your hypotenuse. So it'd be 7 over the square root of 50. Multiply the top and the bottom by the square root of 50 to get the square root of 50 out of the bottom. So I have 7 square roots of 50 over 50. Now you got to reduce this. So that's 7. That's 2 times 25 over 50. I'm hoping that, oh, and just to say it, you can't reduce inside and outside. Okay? Inside a radical, inside a root, and outside a root. If you want me to take the long way, that's 7 square roots of 2 square roots of 25, okay, over 50. That becomes 5. So 7, so I guess I'll be literal and write it in the same order, times 5 over 50. Or it typically gets written in front. 7 times 5 times the square root of 2 over 50. Now this 5 can reduce out. Okay, 1 second, Mr. Keeley's got a question. Okay, so that reduces out 1, 1, and 10. So I have 7 square roots of 2 over 10. Okay, that's it. That would be your answer. Okay. Okay, that looks like it. Thank you guys for your time. Have yourself a great one.